Hello everyone. In this lecture, we are going to see the working of servo motor with Arduino UNO. Actually, still now, what all you have seen, that is the internal work. But coming to the external part of an application, there must be some change, right? For example, I am saying that doors will open and all. That is only we have controlled LEDs and we have controlled the buzzer and all. But in real life, it should give a movement in the original device. For example, if I am saying door locking system, the door bolts should move, right? Those can be controlled using the micro motors. These micro motors are the motors which can be connected to microcontrollers to give some movement in a device or on an object. And these are the internal parts of the servo motor. These are known as servo horns. Actually, we will have three types of horns. I will also show what are those. One more is the potentiometer, as I have mentioned, for adjusting and all. And internally, it consists of a control unit which controls the entire servo motor. And one more thing is that this servo motor consists of one of the motors known as DC motor, direct current motor. With, I know that most of you are aware of these DC motors in from your school life and all, and it is also available in all small remote control toys and all. And this gate train is nothing but on rubbing of these some wheel-like structures one upon the other, we'll get a movement here. You can see where my mouse arrow, right? Here you will get a movement, right? Based on this movement, this servo horn, nothing but this motor is going to run. This is the working of the servo motor. Now let me show what the pins it actually contains to connect with Arduino UNO. Yes, you can see, right? Actually, this is our original servo motor. Yeah, from exterior look, it looks like this, and it consists of three wirings. Two are the common for similar to sensors and all. Here you can see. Yeah, but here the colors we can't decide because automatically with these three colors it will be given. Brown is nothing but negative, nothing but we need to give to ground. And this positive red wire we need to always give to the voltage, nothing but 5 volts or 3.3. 5 volts we will give. And one more thing is the signal, nothing but a PWM. If you observe our Arduino, we will call it as digital PWM. So don't get confusion that whether we need to connect it to analog or digital. For sure, you must and should connect this pin to our Arduino digital pin, and yeah, here they have connected to 9. You can consider any one thing. Yeah, as it is a PWM, remember that one in digital pins which you are using. Let me show the image clearly. Yeah, here you can see some bending curve like uh, shape before some of the numbers, right? Those are actually our PWM. So you should connect to one of those pins so that our servo motor works fine. Now I am going to explain this using our Tinkercad software because while working with real-time systems, I can't always show in Tinkercad. That's the reason only this basic I am showing in Tinkercad. And projects all we are going to see with the hardware components itself. Don't worry regarding it. Yes. Before that, you must ensure if you are working with real-time components, this is the link which is provided in description also for accessing the package server.h header file. You must and should download this. Download zip. Yes, once it is downloaded, servomaster.zip actually. Yeah, this is the GitHub link in the description of video also it is available. Now simply open Arduino IDE. Once it is open, click on sketch, click on include library. Don't click on manage libraries. Manage libraries is for installing the already available packages which will be displayed by Arduino IDE. But we are down since we downloaded zip file, click on add .zip file. Yeah, in my downloads it is available. Click select that one and click on open. Yeah, now you will get output as library install. It is nothing but the installation is successful. Yeah, now coming to one more thing, in Tinkercad software, click on create, click on circuits. Yes, once it is open, from components basic to you need to select all. Then you start typing servo. Yeah, actually micro servo we will call it as, because since it is used with microcontrollers, it is called as micro servo. Yeah, here you can, if you select this one, you are going to get only the component, guys. Yeah, okay, first let me show this component. Yeah, you can see positional and continuous, right? There will be two types. Now, yeah, one more thing, just let me show those pins. Yeah, actually we can use any of the things because it depends, because for this one can be used for 360 degrees, this one can be used only for 180 degrees and all. Based on that we will adjust it actually. So yeah, based on your application, nothing but your device, sorry. Application will be same, but device which you are trying to use, based on your device you need to select this one, and making use of screw you need to fix it on the top of the servo motor. Yeah, now coming back to design. Yeah, you can see orange is signal, red is power and brown is ground. This will be coming with the servo motor. From here we can give our own connections. This is the component. Yeah, since we are dealing with position, it gives us positional. For example, continuous means it will be non-stop rotating like continuous circular and all. Because for example, if you are using, let me say, yeah, I'll keep side by side so that we can discuss the differences first. Yes, if you consider this right one, nothing but this positional. This positional always it will not have a fixed position. It alters continuously. For example, uh, in a way, street a person is walking, and if he is belongs to that street, then it will open slightly. Means nothing but, for example, let me say, based on the person size and all, it is going to give the opening way. Whereas this one, if you see this continuous one, it is like continuously opening one. Nothing but we can say, because with this also you can do circular, but it takes more time if the device is heavy and all, it can't process easily. That can be overcome by this continuous micro servo. Yeah, this is continuous and this is positional. Micro, where we can use is, one is for shopping malls. If you see, they will open the shop doors like shutters. It will be available, right? Those can be opened by making use of this continuous one. Whereas this positional one may fail in such huge applications. That's the main difference. Yes. Now from here, select the servo. Yeah. Already connections will be given and direct code also you can get it. Click on blocks. Go. Yeah. Here you need to select text. Yeah. This complete code you guys need to copy and give these connections with hardware components similarly. Paste the code in Arduino IDE. Yes. You need to paste this code. First, let me compile it. Yes. I did not get any errors because my package is linked. You should also take care of such things. In description of video you can find the GitHub link. From there you need to download and you need to include that zip file library from Sketch, and then you need to run this code, and then you need to upload to hardware components. Let me explain it step by step. Yes. Now coming to this part. Yeah, orange is our digital PWM. So we have connected to digital PWM, that is pin 9. And this red wiring is nothing but positive given to 5 volts. Black is nothing but ground. Yes. Now coming to the coding part. This is our header file, guys. Servo.h is our header file. Our initial position, we any device, it will start from 0 only, right? Nothing but 0 means, we in our terms we can say that it is closed. Then we are giving some rotations to open or something. Yes. Now servo underscore 9. Yeah. Like like we have simply worked with sensors and all into something equals to 9 and all. Digital read, analog read. Like that we are not going to use here. Here we are calling it as servo underscore 9, as 9 is our digital pin. Yes, this servo underscore 9 is what, here we are not saying it as digital pin. Remember, guys, this is the alias name. Alias name of servo I am going to use throughout my program. Here, even you can give your name or my name also, it works fine. Now, coming to the setup part. Servo 9 dot attach. Don't use since it is connecting to digital pin, don't say it as digital read and all. It will not work and it's a blunder mistake. It is related to motors. That's the reason the reading and everything is going to be different. We are going to say attach instead of read. Yeah. And to which pin we are connecting? Digital pin 9. And these values you can give any values. Let me say 5400 or 2500. Any values you can give. Yes, now coming to the loop part. Sweeping. Yeah, 180 degrees means what does it mean? It is just like sweeping one, right? Firstly, I am telling to move in one direction by increasing position one by one. Servo dot right. Yeah, servo dot right, it is nothing but it gives the movement. For giving movement, we are using servo underscore 9 dot right. Dot right is the function to give rotation to the servo motor. And attach is used for reading. Nothing but you need to work from digital pin 9, it will indicate. And right is, remember again and again I am telling, right is for telling the motor to rotate. Yeah, from 0 to 180 we are rotating. This is the first for loop. And in the second for loop, what we are doing? From 180 to 0 degrees we are rotating. Yeah, here we are going to decrease, right? So position we are going to decrement. And here we have given delay time as 15 milliseconds. Yeah, now hope you all understood the code and connections. Let me start simulation. Yes. You can see how my motor is working. Started. Let me say this is the starting point, guys. 0. Yeah, it came up to 180 and again it is going back up to 180. Now, what if I give some 360 degrees? Let me enter. We need to stop simulation if you want to edit the code. Let me say from 360 degrees. Yes. Now again I am going to start simulation. You can observe clearly, right? Yes, it stopped. The reason is that because If we give 360 degrees, it can't support as continuous one. That's the drawback of this positional one. So in this case, you need to use a rotational one, nothing but continuous. Yes. Now I have selected continuous. You can see the continuous rotation. You can see the speed. Sometimes it is coming black to stop and again it is rotating continuously. You can see. This is the advantage of continuous micro servo motor. If you see positional, it is unable to do the 360 degrees one. That's the drawback which is overcome by continuous micro servo motor. Actually, what are these parts are called? Let me open. Those are known as servo horns. Based on the servo horn you are using, the rotation angles are dependent based on that one. For 360 degrees one, we need to use the continuous servo horn. If you want up to 180 is maximum enough, then positional will be enough. And one more thing, let me keep it as 180 only because I'll show 180 with the same continuous one also. Yes. Yes, guys, this is 180 for positional one. For continuous, if I say, yeah, it is rotating in such a speed that we are unable to even notice in which direction or how is it rotating. This is that's the reason for smaller or low movement one. For example, if we are saying some parking lots and all, there will be some like opening means allowing the cars and again something like it will close, right? That such applications are controlled based on this positional one. Yeah, near toll gates and all are also available, right? Based on your FASTag or those all things, it will verify, and then once it is verified, it will open the path for allowing the vehicles. That's the difference between positional and continuous micro servo motors. Hope you all understood. And in the next lecture, we are going to see with the hardware components. And if you are facing any doubts, you can drop in the comment section. Thank you.